Hey guys, so today we're working with squares, cubes, square roots, and cube roots of algebraic expressions. We've already worked with squares and cubes of algebraic expressions, all raising to any power for that matter, when we worked with the laws of exponents earlier this year. So we're just going to recap that, but I want you to have a look at these 4 examples and first pause, have a look at it and see whether you can figure out what's going on there as to finding the roots, square roots that is specifically of algebraic expressions. So what I noticed was that and just think about it carefully quickly, what is the function of a square root? It tells you to determine the value that was multiplied, that would be the root value, that was multiplied by itself to give you the answer in the root. And so the number multiplied by itself to give you x squared would have been x, isn't it? Because, let me just get the pen going here. Okay, red. Right. So if I have x times x in the root, that's x squared, isn't it? And therefore x is the root number multiplied by itself to give you x squared. But the shortcut rule, which is easier to use, would be that you divide the exponent of your variable by the exponent of the root. Now, if it's a square root, there's a little 2 over there. And therefore, 4 divided by 2 gives you the 2. All right, same goes in the next example. 8 divided by 2, the invisible 2 that's over here, gives you 4. And then, in the last example, note that we do not use the special rule we use for the variables for the normal numbers, the 25 in here, the coefficient of the variable that would be. So the square root of 25, you're still asking yourself, what number was multiplied by itself? And that would be 5, we all know. So 5 is the answer to the coefficient, but then we divide the exponent of 6 value here by 2, and that is how they got to the exponent 3. All right, so let's have a look at another one quickly. If we have 36x to the power of, let's make it 10. Then, remember, square root of 36. What times what by itself gives you 36, and that would be 6. And then x to the power of 10, we square root by taking 10 and dividing it by 2. So it's x to the power of 10, that is divided by 2. So the final answer is 6x to the power of 5. Great. So what if we have let me just get the pen again here, a cube root. If I have a cube root, let's see here, cube root, the rule stays the same. You divide the exponent of the variable by the exponent of the root, in which case this time around we have the exponent of the root being 3. So if I have 27x to the power of 3 cube rooted, we would have the cube root of 27. You ask yourself, what times what times what gives you 27, and that is 3. And then for cube rooting x cubed, you divide 3 by 3. So it's x to the power of 3 by 3 divided by 3 technically, and that gives you 3x to the power of 1, which technically we don't write. Just another example, the cube root of 64x to the power of 9. And that would be, cube root of 64 is 4. And then x to the power of 9, which is divided by 3 in this case. And it gives you 4x to the power of 3. Right, I think that's enough of that. Let's move along to how to square or cube or raise to any power for that matter an expression. Okay, especially with algebra. So number 1, let's say we have 2x cubed all cubed. Remember, you raise each of the factors 2 and x cubed to the power of 3 as in a distributive matter. But then it would be 2 to the power of 3 is 8, and x to the power of 3 to the power of 3 would be, remember the law of exponents say, if you raise a power to a further power, you times those numbers in the exponents, and 3 times 3 would be 9. So that would be the result of that. If I have negative 3x squared to the power of 4, you're asking yourself, what is negative 3 to the power of 4 and what is x squared to the power of 4? A negative 3 to the power of 4 gives you positive, because it's to an even exponent, positive 81 x to the power of, and then 2 times 4 is 8. And there we have it. So that's just a quick recap on squaring or cubing an expression. So if we have a method that we can write down, it is that you divide the exponent of the variable by the exponent of the root. Okay, so that's finding the root of a variable. And remember, you first simplify underneath the square or the cube root, or inside the brackets before you square, cube, or find the root of any such thing. So in the examples over here, first thing, I am going to add the like terms. The x squared terms over here. 9x squared and 16x squared gives you 25x squared. So then you find the square root after that. So square root 25 is 5, and the square root of x squared is x to the power of 1. Remember, divide the 2 by the invisible exponent 2. If it's any other power in the exponent of the root, we would literally write it. And then in the next example, as you can see, we first need to tidy up here. We need to raise each of the factors inside this second term to the power of 2. So square root of, and then 4x squared times x squared gives you 4x to the power of 4. Now in the root we were multiplying the same basis, and for that the laws of exponents, they add the exponents, and that's why 2 plus 2 for the exponent became 4. Plus then 3x all squared means we're going to raise 3 to the power of 2, and that is 9. And x to the power of 1 is raised to the power of 2, and that would just be 1 times 2 is 2 for the exponent. So now we can find the root of this term here, and the square root of 4 is 2, and the square root of x to the power of 4 divided by the invisible exponent 2 over here gives you 2, so it's x squared. Plus, and then it gives you 9x squared, stays 9x squared, and now lastly, according to BETMAS, may we add together these like terms. 2x squared plus 9x squared then gives you 11x squared. Next example, we have to simplify each of these terms in the expression firstly. So we luckily have like terms inside the root, which we need to simplify first. And so the cube root of 27a to the power of 3 is what the first term becomes, and from that we subtract a multiplied by 3a, which is 3a squared. Then negative a is multiplied by negative 2, and negative times a negative is a positive, and then 1 times 2 is 2, and a times no variable is a. On to more simplification over here. We now find the cube root of 27a cubed. So cube root of 27a, 3, and then the cube root of a cubed, that exponent 3 divides by that exponent 3 and gives you 1. So a to the power of 1. And then it follows with minus 3a squared plus 2a. And then we have like terms of 3a and 2a. And if we simplify that, 3a plus 2a is 5a. So I'll write it in descending powers of exponents, and that's negative 3a squared plus 5a then if we simplify the 3a and the 2a. Alright guys, please do ask if you need any help after you've watched this video, and then you can do the work for Spot On Mathematics Grade 8 Activity 8.4.